Hi everyone, I'm Giacomo Capitani from the University of Modena and Reggio Emilia, and I'm going to present you our WA-Civil paper, ClusterFix, a cluster-based debiasing approach without protected group supervision. Artificial intelligence systems may suffer from inductive bias, from data or algorithmic design, so answering their reliability necessitates a broader consideration behind performance metrics. Furthermore, minorities or underrepresented groups may encounter elevated error rates within these systems, so this underscores a critical concern wherein deep learning models may exploit spurious correlation, resulting in bad consequences. Our goal is to train a model to mitigate performance disparities among protected groups without exploiting such information during training. So, for example, in this example, protected attribute is defined by the gender, the background, or whatever. We aim to achieve this objective while ensuring satisfactory average performance. Yep. There has been a notable interest in the concept of fairness and robustness in recent years. Group distributionally robust optimization offers a framework for answering optimal outcomes, even in scenarios where there are shifts in data distribution. However, a significant limitation is its reliance on sensitive attributes annotation, often unavailable in real-world datasets. So our framework addresses this challenge by using clustering as segments classification as a proxy. Unlike other approach that attempt to obtain worst-case generalization without relying on prior knowledge, our approach shares similarities with two cluster-based debiasing strategies, namely George and BPA. And while both of these methods employ pseudo-labels to segment the datasets into clusters, it has been observed that data is susceptible to overfitting, leading to suboptimal performance on real-world datasets like Celebar. To address this challenge, we aim to learn new features to identify a common per cluster attribute. In other words, this means looking for features consistent with the original cluster, but different from the target attribute. And upweighting samples belonging to the cluster with the high cluster loss, we can identify data distributions that enhance model robustness and mitigate bias. So, the main objective of the optimization process is to learn how to classify the target, which is achieved through task-weighted classification loss, and each sample's classification loss is weighted by a factor W, which reflects the significance of the cluster to which the sample belongs. The weight is so determined based on the average loss concerning Y and the cluster loss concerning the cluster segments. To evaluate the proposed methods, we calculate the accuracy of every group, and the bias attribute is the gender for Celiba and the background for waterbirds. We report the results regarding average group accuracy and worst group accuracy. We show how ClusterFix outperforms competitors across all the scenarios. And here we can see activation maps using some explainability methods. So we can see the empirical risk minimization method emphasizes features not correlated with the target's attribute. In this case, the wearing necklace target and the receding hairline, while ClusterFix works quite well. So, thank you for your attention, and we invite you to join us for a discussion and the WCU poster session. Bye.